Hello everyone. In this video we will study a family of uh, polar curves called roses. You will see in a bit why do we call them roses. Okay, so let's start with one example. R equal to cosine 2 theta. Recall that if this was just 2 cosine theta, that's just a circle. But now there is a multiple of theta inside cosine, and you will see that that would change the story quite a bit. Okay, so the graph for cosine 2 theta is something like this. So it goes from 0 to pi over 4, and then pi over 2, 3 pi over 4, and then up to pi. Why knowing this graph is important for me? Because I can now see what are the key values for theta and try to figure out the things based on that. So here I'll start with 0. So cosine of 0 is 1, so this will be 2. And at pi over 4, cosine of pi over 2 is 1. That will give me, this is cosine of pi over 2, which is 0 here. So it means what? At 0, we start with R2, so 1, 2. And then at pi over 4, we go back to 0. So that means that as the values of theta increases, we have to get closer and closer to 0. Now, from pi over 4 to pi over 2, so at pi over 2, we have 2 cosine of 2 times pi over 2, which will give us cosine of pi. This is negative 2. Okay, but let me just pick one more value here. For example, pi over 3. So 2 cosine of 2 pi over 3. Cosine of 2 pi over 3 is negative half times 2, it is negative 1. So at this angle, r is negative, so it means that I have to go backward 1 here. So that is what I have to keep in mind, keep track of. And then at pi over 2, r is negative, though ray is up to here, but I have to go negative side and get this one. Okay, and you see that, then that means that in that interval I'm going to form this part here. Now from pi over 2 to 3 pi over 4, so 2 times cosine of 2 3 pi over 2, this is cosine of 3 pi, yeah? 3 pi over 4, sorry. Then that will be cosine of 3 pi over 2, which is 0. So it means that at 3 pi over 2, we are going to go back to the origin. But one more step here, for example, this one, 2 pi over 3, so 2 cosine of 4 pi over 3. This is like cosine of pi over 3, negative of that, this will be negative 1 again. So it means that at 2 pi over 3, this is the ray, but r is negative, so it will go up to that point. Okay, so from this we turn around and go to 0. Okay, where are we? 3 pi over 2, 3 pi over 2, and we continue with the other value here. So from 3 pi over 2 up to pi. So the next value is pi. So 2 cosine of 2 pi. This is just 2. So at pi, we get to the point 2. But something like 5 pi over 6, if you plug in there, so 2 cosine of, it will give us 5 pi over 3, which will be 1 here. So that means that we are going to have 1 here. So this story will repeat itself. It will go there. It will go, or maybe I should, okay. It goes up to that point. And then we continue, goes from here to there, and then from here, oops, no, didn't work nicely. It's always, okay, something like that. And then from there, it will go something like that, and then goes like that. And here we are. We're going to have a 4-leaf rows. 2 times cosine 2 theta. Note that this 2 just tells us how big, how long the leaves are, yes? But this 2 inside basically tells you how many times you go around. And it's not straightforward to see that formula, because there are sometimes some of these guys go around and come back over the previous ones. Okay. And in general, let me just write it here. R equals to 2, well, not 2a cosine of b theta, or R equals to b a sine of b theta, for b not equal to 1 gives us roses. So if b is equal to 1, you know that those are circles. But when b is not equal to 1, those would give us roses. Okay? For example, this one here for sine 3 theta, I won't do all the steps. I'll just draw some of the important ones. Let me pick my copy and then paste it here. So here, for example, starting from 0, we will stay at origin. And then when we go from 0 to pi, what is this value that will give me pi over 2? So up to pi over 6. Yes, so it will give us 4 sine of 3 pi over 6. That will be 4. So at pi over 6, we will have the value 4. But this should be obtained as we move from 0 to 1. So it will be something like, not very nice one. Okay. And then from pi over 6 to pi over 3, which is this guy here. At pi over 3, this is 4 times sine of 3 pi over 3, which is 0. So we have to go back to 0. And for that part, as we move, yes, so oops, as we move, sorry about that. So as we move at 0, we get this one. But then from that to pi over 2, this will be for sine of 3 pi over 2. This is going to be negative 1. So from that part to there, maybe I should make it, this part is 1, then that is 2, this is there. And then this part here, which is 3, pi over 2, we get negative 4, actually, not negative 1. So this will turn around and go 1, 2, 3, 4 here. So we'll go something like that, and then it will move back up. Something, oops, should have done step by step. Okay, that one. Then it is going like, it is going like that there, and then from there you go up to this guy here, and then here. And it's interesting to know that, okay, so this is 1, 2, then this is 3 here, then there's 4, 5, and 6. 4, 5, 6 are, this is 4, this is 5, and this is 6. Up to pi, you go all over this rows, and you get 3 leaves there. Then from that point, you repeat exactly what we had before. So it will go over the rows another time. And yes, so you have to be able to see what is going on and be able to sketch these ones. In general, you have to know how these graphs work.